Hi everyone, my name is Alex Kingsbury. I'm from Enlight, and today we're going to hear about a really interesting project that's happening. ZF are an automotive company, and they are looking for all sorts of improvements in our PBF, and they're investigating every single option, and DED as well, I will add. So today we're going to hear from Dr. Ignacio Lobo Casanova from ZF, supported by their very wonderful partners, Nikon SLM Solutions with Benjamin Haas. Thank you guys, take it away.
Thank you, Alex. Thank you for having us. Thank you, Enlight, for giving us the opportunity to give some insights into what we do in terms of beam shaping. You might actually be a little bit surprised because that's the first time that ZF and Nikon SLM are jointly together on a stage. So what brings us together, Ignacio?
Yeah, first of all, thank you very much for the time today. Benjamin, yeah, a good question. We started the cooperation some years ago, discussing about how to applicate these additive manufacturing technologies within ZF. And then in this discussion, we started with one idea. The idea was nexam. It's a project that we are running right now, and where we see that is the next generation for additive manufacturing parts. Maybe you can explain a little bit what we are doing together.
Absolutely. So Nexamo is a publicly funded project, so that's why we can talk about it to some extent. Quite interestingly enough, it's a very heavily funded project. I mean, usually those research projects are, somewhat funded, but you never get that big ticket. That's actually quite a big ticket because that's a 16 million euro funded project. And the main goal is really to digitalize the automotive production. And of course, additive manufacturing plays a role in here. And so that's why we really wanted to join that project. And as you can imagine, if it's a 16 million euro funded project, it's not just the two of us. So it's really a variety of different companies, also different technologies. As Alex mentioned, it's not just laser powder bed fusion, but also DED. And they're really across the entire process chain. And what was the reason that ZF decided to join Nexam in the first place?
Yeah, we have to think about the demands for the automotive supplier. So most and most time is the technology is coming from our demands, so from our customers, and for our internal demands, for printing some kind of part toolings, jigs, and prototypes. That is the use case that everybody knows about the technology. But the question is, after setting up our production hubs, we have to go to the next step, how to prepare ourselves for the serial production. And then the question is, if you want to go into the serial production, you have to automate the additive manufacturing, the complete process chain. So not only printing, you have to consider the post-processing, you have to consider the quality assurance. So taking care about the current situation of the automotive supplier, about the automotive mark, you see that we have shorter time for the development. We need to speed in our development of the parts. We need to produce our parts in a high quality, and we have to assure the quality of the parts. And this was the main reason that we want to implement and then to focus on to set up a new project, a new way of working for additive manufacturing to assure all this challenge, and then to take care about this challenge and to set up the production of the future for automotive parts.
I think that's a perfect segue where we come into play then. So of course we also have a heavy interest in participating in that project. As you might know, Nikon SLM Solutions has been very active in the automotive industry throughout the entire world, mainly because we have quite large systems, but also we are quite productive and we have a vast experience in reactive materials such as aluminum alloys and even other materials like stainless steels or even tool steel. So across the entire automotive industry, we do have quite a solid footprint. And of course, we would like to continue leading in that industry. Now, especially in automotive and series production, there's one KPI that's always very, very critical, and that's cost per part. So especially when you start thinking about serial production, people really start fighting about the 10th digit after the decimal because they're really, really that cost sensitive. So for us, it's a primary goal to drive down cost per part as much as possible. And as a machine provider, there are, of course, a multitude of different ways on how to achieve a very low cost per part and essentially a very high throughput of a machine. And we've looked at all kinds of things. So we looked into increasing the number of lasers. We looked into having removable build cylinders so that we can pick up production in matters of hours really instead of days. We looked into automating most of the process steps so that we can really get a high throughput and therefore drive down costs. So it's really a multi-dimensional exercise to drive down costs. And along that journey, we also started looking into, well, what else can we do? Because quite frankly, what drives down cost per part? Of course, that's like your investment, but of course also the uptime of the machine, the efficiency of the machine, and you can really do a detailed total cost of ownership analysis. To one aspect, it's really about processes as a whole. So once the part or once the build job finishes, what do you do with it? How quickly can you bring the machine up to speed? That's really more on, let's say, the ecosystem around the machine. What's really interesting, and that's of course, where we also come into play, is within the machine, what's happening in the process. And of course, you can start thinking about, higher laser power, more laser, higher layer thickness, just to increase productivity in the process itself. And then when beam shaping came along, we also looked into that, of course. I mean, there are other ways of, driving productivity by modifying a laser beam, just like by defocusing or zooming. But we believe that beam shaping actually plays a vital role into driving productivity even further. So, Ignacio, what do you think? I mean, what are some of the benefits besides productivity increase that we could also get from beam shaping?
Yeah, that is in the same way you say, that is we have to go in detail. So not only to consider, the process and as before, we have to improve it. And then, for example, for this beam shaping, we have the expectation that by adapting the focus of the laser, we have better quality of the parts. We can improve the quality to avoid porosity that we have right now with the current system. We can increase the speed of the manufacturing part by focusing in a detailed area, for example, for the contour and for the support structure where you don't need the high performance of the material. You can act and then you can melt more material at the same time by controlling this melting process. That is one of the focus we have in the project, to select and then to analyze the additive manufacturing technologies for powder and for DED. And that is the cooperation we have together with Nikon SLM, here together with Enlight, to focus on this area, to look for the advantages, the disadvantages for the technology, of course, focus advantages. This is the reason we are here today. And that is at the end of the day, we want to increase the productivity to assure the quality of the parts, and then to be sure that our final customer, is going to receive the same quality. It depends not on the day, at the same speed and the same productivity.
Yeah.
And maybe so, as I told you, is in the project, it's not only 3D printing. There are another aspects that we have to consider after the printing process, what's happening with the post-processing, quality assurance. That is something we are taking care in the nexam project. Maybe we can go in a deep dive next year when we have more facts and more information. We started the project this year in January. The cooperation with Nikon SLM is running a longer time, and maybe next year we can have a look on the other quality assurance that we have and that we can take care in the project.
Actually, that was a good keyword, so longer time. So we've also been collaborating with Enlight for a little longer than just now. We really started by looking into that technology to really understand what is happening, because again, it's fairly new to additive. It has been around, of course, for a little bit longer, but what does it really mean to use beam shaping in additive manufacturing? So some of our customers have been utilizing Enlight lasers in their SLM 280 machines, for instance, a couple of years ago. There have been great speeches also by LPT Erlangen as well, for instance. So they are investigating how beam shaping really works and to really understand the mechanism. That's of course important for us as well, because we wouldn't implement it if we didn't know really what was happening. At the same time, and this is why I like this project so much, the one aspect we do need to look into like very academic research and really understand what is happening. But on the other hand, the project really gives us the opportunity to link the learnings also to an end user and end customer, and also of course link it all together to really drive down cost per part and actually increase productivity. Because I mean, some of the automotive parts that we see today, that's not really a part of the project, but I think it's a good demonstrator because it actually is an automotive component. And I mean, some of the benefits of AM in automotive is that you can have different kinds of you can functionally integrate different parts, but that of course also means that you have some bulky areas, some finer lattice structures as well. And if we were to use beam shaping in that, that's actually where we see a giant benefit. And of course, switching those beams in order of just a few nanoseconds can be really, really fast. And of course, that helps us really to create these kinds of components even better than we actually can do it today.
Yeah, that is the question: to use the right tool in the right position at the right time. And that is the laser. You have the possibility to adapt the laser to the demands that you have in the part. And by using this beam shaping technology is the possibility that we see for the future to have more powerful parts, to increase the performance of the part, and of course, I repeat, the quality. The quality is really, really important. Without quality, we can do nothing. Okay, and that is what we are doing in this working package of the project, and the quality assurance is going to be considered and to be released in the next steps on the process step in the project, and then we will evaluate, as Benjamin told us today, what is the influence of this beam shaping technology against the other technology, what are the benefits, and then why not to select the right technology for the right part, to implement everything in a digital way in this manufacturing planning tool that we want to deliver and that we want to develop in the nexam project, by selecting the right parameter in the beginning of the part and then adjusting the production and the production planning to the right process.
And I think you had a very nice reference, right? It's like a navigation system.
Yeah.
Can you explain how that works?
Yeah, this is more on the global area of the project, of the nexam project. As I told you, you have additive manufacturing lines, you have post-processing lines, and you have the quality assurance lines. Everything is connected with automated, so with AMRs, AGVs, and cobots. So it means that we want to make a island of manufacturing process that is working without, let's say, people. Let's say to have the quality assurance in a better way. So when we started, the idea behind the nexam project is somebody within ZF is able to upload a part, like this one, for example, make a check analysis if the part is printable or not, by doing the modifications that you need to do maybe in the design. You upload final data to the production, you select the amount of part that you want to need, and then you started with the production planning. By starting with the production plan, the current situation with SAP, for example, is you select process 1, process 2, process 3. If something is working good, but when something working not good, then you have to realize and then to check what happened in the process step 2, and you have to adjust your product, and you have to adapt your product planning, and so on. In the nexam project, we want to make one intelligent production planning, a live production planning. So it means we are going to send the order to the AGVs, to each machine. Each machine is connected to the brain of this production planning. By connecting to this brain, each machine is sending the information, what I am doing right now, what is the status of my process, I am going to take longer or not, and the AGV who is responsible to transport the part from A to B, they will select if B is possible to be considered or not. In the case that they cannot go to B, they are going to adjust this process live, in a lifetime, not like right now, without people and so on. We can adjust the process step of live, and then you can readjust the production planning. I like to make a comparison with a navigation system. If you want to go to Frankfurt to Berlin, you go in the car, you put Berlin, and the navigation system is going to select the best highway, the best way to go to Berlin with different criteria. You want to be faster, you want to save fuel, you want to go, to have the best wonderful place to visit. At the end of the day, you have three alternatives. You select one, and then you start here in Frankfurt when you are close to Würzburg, so you have a traffic jam. What happened? The navigation will readjust the route, the planning. It's going to give you an opportunity, and that is the way we want to work, like a navigation system. When you start the process planning, if you have a problem, lifetime to readjust the route, to readjust the process planning, and then to fulfill your goal, go to Berlin in the best way and in the best time that you considered before.
I mean, we would like to equip you, of course, with the fastest car to do that. So, like being the fastest machine, of course, to do that as well. So this is essentially why we think beam shaping can be very interesting, just because of the multitude of different opportunities that this gives us. But we also see, having the powerful collaboration between ZF and Nikon SLM, and of course the entire nexam project. I think that will really be a game changer in terms of how that technology can be implemented by Nikon SLM. And at the same time, I do have to say that, of course, like a serious production automotive, I think that's one of the most challenging customers you can have in terms of cost per part, because as I said, you really have to get it down to the nitty-gritty detail to really be cost efficient, because otherwise that won't be a business case.
No future.
Exactly. So we think beam shaping can definitely play a role in that. And we're very thankful for the collaboration here, but also, of course, with the collaboration with Enlight.
Thank you very much for my side. And to be honest, I am really impressed about the steps that we covered in the project right till now. and then let's go ahead, and then let's look forward for the next steps in the project.
And I think in a year from now, we might actually be sharing some more results that we can get off the project. So we just wanted to give you a little sneak peek into the project we're working on. But next year, we will have some more details.
Sure.
Thank you very much.
Okay, so any questions whatsoever?
Yeah. Christian? Yeah.
Thank you, first of all, for the great presentation or the conversation here. I will have a question to Ignacio. You are really, let's say, looking into the details, how to save costs, how to design the part and everything. Quality insurance is very important. Let's say, are you able to lower quality factors like density? I don't know, let's call it 98% of density, for example. Is this something you're looking into, or maybe to improve the speed of the process and maybe bring even further the costs down? Have you some open mind for things like this as well, or 99.99 needs to be always?
You have to be open-minded. You have to, we need to consider the functionality of the part to check if this part, because in the past, a lot of designers, they decided to put some information in the drawing, let's say some tolerances, and then it's, to be honest, you have to adjust the product design to the technology. I was working a long time in the production development by making parts with composite materials. Now it's additive manufacturing, and you have to change the mindset of the people in the development. And then to consider, do we need this 99%? It is needed or not? Of course, there are some parts like a valve block where you have this density and you have the tightness requirements that is the way. But for other parts, you can get another kind of approach, another redesign of the part, and then avoid these high cost tolerances that is getting nowhere. So at the end of the day.
Okay, thank you. So it sounds like you're looking already into it and exploring these areas. Yeah, okay.
You have to.
Very interesting. Thank you.
Great. Let's thank our speakers one more time.
Thank you.